Okay, ready when you are.
Okay, so today we'll be telling you guys a little bit about the calculus involved in bowling.
Alright, so the earliest form of bowling dates back to the ancient Egypt and ancient Roman Empire. Now, these balls weren't made like how they are today. They're made out of husks of grain covered in leather. Other balls have been found made of porcelain and plastic have been found. Bowling games of different forms have also been noted by Herodotus. Now, there are three ways to bowl. First way is the straight, conventional way, which requires you to go the two knuckles deep on your fingers. This allows for the most control, but will generate like little to no spin. Trust me, I know. All right, the second thing is the no thumb. So you only use your two fingers. This generates a lot of spin, but will force you to become less accurate. And now the most common type is the fingertip. It has good control and spin and is widely used by the PBA players, including me.
Okay, so scoring is kept by adding the numbers of pins knocked down in each frame, and if you knock all the pins down in one or two tries, then you get extra points. For example, when a strike is bowled, the bowler is awarded the score of 10 points, plus the total of his next two rolls in the next frame are added to that score. And then for a spare, you get the 10 points, and then the total of the pins knocked down in the next roll only. And so we'll talk about a little bit about the volume of a bowling ball. Archimedes was the first to calculate the volume of a spear. He was born in Syracuse, Sicily, around 287 BC, or about 1800 BC, before calculus. He studied at Alexandria in Egypt under Euclid. He was the inventor of the lever, the compound pulley, and the Archimedean screw, which is seen in the top right of the screen. That kind of gives an example of it. And he was basically the person who founded the basics of calculus. He worked extensively with volume, surface area, center of mass, and he was one of the first people to accurately approximate pi. And in calculus, using integration, he was the first to kind of form that. He was the one who used salami tactics, or cross sections, which is seen in the right hand. It kind of shows cross sections and how he approximated the volume of a sphere, and he came up with the formula for a sphere, 4/3 pi r cubed.
Alright, so most bowling balls are two parts, an inner core and an outer shell, and the average diameter of these balls is around 8.5 inches. The inner core can be different shapes as seen in the bottom right to create specific hooks and spins that the bowler wants. But the most basic one is the diamond shape, and that's what we'll use to find the volume of the outer shell. So the ellipse equation is the outer diameter, and the piecewise function represents the inner core. And in order to find the volume, we would need to take two integrals. Alright, so to take two integrals, you would have to go from -5 to 0 and 0 to 5 of the bigger function minus the smaller function. So you can be seen here, this is the bigger function squared minus the smaller function squared. And do that 2 times and times it by pi. Do the calculations, and this is what you get as the 2, and if you combine them, that's the total volume of the outer shell. So the total volume of the outer shell is 281.36 inches squared.
And then we'll talk a little bit about parabolas. Parabolas were the first recorded work of parabolas was done by Menaechmus in the 300s BC. He worked with cross sections as well. And Galileo further extended the work when he said that the path of a projectile follows a parabola due to uniform gravitational acceleration. So in order to get the optimal strike, you need to hit the pins between the 1 and the 3 pin, or the 1 and the 2, depending on if you're left or right-handed. And that optimal angle is 6 degrees, which is only achieved with a fingertip grip. And you can kind of see by the graph that would be the path of the bowling ball. And then straight balls, the most you can get is about a 1.75 degree angle.
Alright, as stated before, the ball should hit between the 1 and the 3, or 1 and 2 if you're left-handed. And since the length is 60 feet from the edge of the lane to the head pin, which is the one pin, and from the distance from the gutter to that one pin is 1.75, we can calculate that angle. So we calculated that angle, which was 6 degrees. That would be considered the perfect strike. But other factors such as your speed and rotation cause this angle to differ like per player to player. And the only way to achieve this is by curving the ball. Now, in order to have the ball strike between the 1 and the 3, the path of the ball should be modeled by this, which is the tan pi over 30 over 60 x squared minus tan of pi over 30x plus 1.75. So in order to find the actual length the ball will travel, you would take the integral from 0 to 60 of the square root of 1 plus the derivative, which is found here, square that. And then the actual length that the ball travels is only 0.11 feet more. So a total travels of 60.11 feet.
Okay, so force. Obviously, we know Newton was worked with force extensively, but before him, Aristotle had concepts concerning force, such as motionless objects on Earth will stay that way if left that way, which corresponds to Newton's an object in motion tends to stay in motion. And like I said, Newton developed the three basic rules: an object in motion stays in motion. And then we have his second rule, which is force equals mass times acceleration, but it originally wasn't that equation. Originally, he said force equals momentum over time, and momentum is mass times velocity, or kilograms times meter per second, and then that would be over time, which is how you get F equals ma. And then his third law was for every action there's an equal and opposite reaction. So we calculated the average bowling ball is about 16 pounds or 7.2 kilograms. And because of the force of friction on the lane, a bowling ball loses 3 to 3.5 miles per hour, and it takes about 2.5 seconds for that ball to roll 60 feet down the lane. And it is said that 18 miles an hour is said to be the optimal speed when striking the pins. So if we take some calculations, the mass times the initial velocity, or the final velocity minus the initial velocity over the time, then we know that the average friction force over the 60 feet of the lane is about 4.07 newtons. And also, since the ball decreases 3 to 3.5 miles per hour while rolling down the lane, then you would need to initially roll the ball at about 21 miles per hour, which that would mean in order to get 21 miles an hour, when you first roll the ball, you would need to apply about 136.5 newtons of force.
All right, and then we'll talk about the rotation of the bowling ball. Isaac Newton was the first to work with laws of rotation. He had 3 laws similar to the laws of motion that we know now, and an object in motion tends to stay in motion, so the angular velocity remains unchanged in the absence of a torque. All right, let's watch this great rotation of a bowling ball. Oh, look at that spin. Beauty and strike.
Yep. If we can go back and look at this really quick, we can give you an analysis. If we pause the video right about here, we can see, you can kind of see how he rotates his hand around the ball when he lets it go.
So right here you can see the force is applied, and that causes the ball to spin and roll like that.
That was a great strike.
10 out of 10.
So like we said, in order to curve a bowling ball, you need to obviously roll the ball sideways in order to get that sideways angular velocity. And he was using, is that the fingertip grip? Yep. So you have your middle and ring finger and the thumb, and you hold it behind the ball, and then you rotate your arm sideways when you release the ball. So rotational momentum, like we said, when you bowl the ball, you need to apply a force of 136.5 newtons. And when you release the ball, your hand is on the side in order to get the ball to spin. As you can see, the force is applied right there where his hand is. So the radius of the ball is about 10.8 centimeters, and the angle, assuming at 0 degrees, is directly towards the head pin. His hand is about 110 degrees then. And we use the equation torque equals the radius times force times the sine of theta, and we found that the torque on the ball was 13.85 newton meters.
All right, and that's our works cited. Thank you for watching our presentation on bowling.